Suppose that a positive function f is given, then the definite integral from a to b of this function f, so f of x dx, is simply equal to a, where a is the area that's enclosed by the function f, by the x-axis, and by the line x equals a and x equals b. When the function f is negative, so it's below the x-axis, then the definite integral from a to b of this function f, so f of x dx, is equal to negative a, where a is the area that's enclosed by the function f, by the x-axis, and by the line x equals a and x equals b. When the function takes both positive and negative values, then to integrate such a function from 1, let's say, up to 5, I can decompose this integration into 3. So this integral of this function f of x dx is going to be equal integral from 1 to 2 of the same function f, so f of x dx, and then plus the integral from 2 to 4 of the same function f of x dx, and plus the integral from 4 to 5, again the same function f of x dx. Now the first integral is going to be equal, let's say, a, and a is the area underneath the function f. Now the second integral plus is going to be negative, let's say b, where b is the area between the x-axis and the function, and lastly plus c, where c is the area underneath the function f between 4 and 5. So here's one example. We can show that this definite integral from negative 2 to 2 of this function is 2 pi. We know that the equation x squared plus y squared equals 4. This is exactly the equation of the circle. That's exactly the equation of the circle with radius 2. 2 squared is 4. So the radius of the circle is 2. Well, we know how to compute area of the circle. But first, let's compute y squared. So this is equal to 4 minus x squared. And when I take the radical of both sides, that will give me y equals the radical of 4 minus x squared. This is exactly the upper semicircle. And so we can view this curve as a function. So the function is y equals the radical of 4 minus x squared, which is exactly the function that I wanted to integrate from negative 2 to 2. And so the definite integral is simply the area of this semicircle, which is exactly 2 pi. Here are some properties of definite integral. The definite integral from a to a, the same number, of any function f is 0. For example, if I want to integrate from 1 to 1 any function, let's say sine x, the trigonometric function, this is 0. Or when I want to integrate, let's say, from 0 to 0 of the exponential function e to the x dx, this is 0. Reversing the limits of integration changes sign to the opposite, so integral from a to b of any function f, that's going to be negative integral from b to a of the same function. So take, for example, the very simple function y equals x. Here's the graph of this function y equals x. Consider this function from 0 to 1. So here's the function y equals x. And then we know that the definite integral from 0 to 1 of this function x dx is equal to 1/2 That's because this is simply this area, this triangle, which is 1/2. So now take this integral, but now from 1 to 0 of this function x dx. So this is equal negative the integral from 0 to 1 of x dx, and so this is equal to negative 1/2. Integration is a homogeneous operation in the sense that when I want to integrate a constant, say c times a function, that would be exactly the same as when I would be integrating the function and then multiplying the result by the constant c. So for example, let's say integral from 0 to 1 of, let's say, 3 times sine x dx. That's the same as 3 times the definite integral from 0 to 1 of this function sine x dx. Integration is also an additive operation. This means that if I want to integrate the function, which is a sum of two functions, that would be the same if I'll integrate the first function and then the second one. So for example, take this integral from 0 to 1 and take two functions. Maybe one is the exponential function and the other one is the trigonometric sine function. Let's say I want to integrate this function. That would be the same as the integral from 0 to 1 of the first function, so the exponential function, and then the integral also from 0 to 1 of the second function, which is the sine x dx.